Base 2 or binary number system. The base 2 number system is also called the binary number system. The prefix bi means 2 in Latin, so this system contains only 2 digits, 0 and 1. That means every number can be represented by some combination of zeros and ones. But how? Just like the decimal number system represents the value of each place by multiplying each place by 10 to a power, the binary number system represents the value of each digit by multiplying each place by 2 to a power. The binary number system is the system understood by machine code and translates directly to bits. The numeral 110BIN does not have a value of 110, or the numeral 110DEC. This is why notation is so critical. In the base 2 system, the rightmost digit is multiplied by 2 raised to the power of 0, which is 1. Then each digit to the left of that is multiplied by 2 raised to 1 greater power. In this case, the places will go 1s, 2s, 4s, 8s, 16s, etc. This is where it gets a little tricky. Our natural instinct is to say that 110 BIN converts to a value of 420. That is incorrect. Remember what happened in base 10 to the numbers after they were multiplied by 10 to a power? The values of each place were added together. So in this case, 110 BIN is equivalent to the number 4 plus 2 plus 0, which would be 6 in the base 10 number system. Let's find the value of 10111 in the binary system using the table below. Each digit's value is determined by its place in the number. Multiplying the first and second rows yields the value of each digit. Adding across gives the number value of 10111 binary, which is equivalent to 23 in the decimal number system. Alright, so here we have 2 to the 0 power, which is 1, 2 to the first power, which is 2, 2 to the second power, which is 4, 2 to the third power, which is 8, and 2 to the fourth power, which is 16. So we multiply 1 times 1 and get 1, 1 times 2 and get 2, 1 times 4 and get 4, 0 times 8 and get 0, 1 times 16 and get 16. Then we add these together. 16 plus 4 plus 2 plus 1 gives us 23. This is the method used to convert from the binary to decimal number system. Fill out this chart to determine the decimal value of 11001 in binary. Alright, so since we're converting from base 2, we fill this row with 2 to the 0, 2 to the first, 2 to the second, 2 to the third, and 2 to the fourth. We fill this row with whatever these are. So 2 to the 0 power is 1, 2 to the first power is 2, 2 squared is 4, 2 cubed is 8, 2 to the fourth power is 16. Then we multiply this number by this number. 1 times 1 gives us 1. 0 times 2 gives us 0. 0 times 4 gives us 0. 1 times 8 gives us 8. And 1 times 16 gives us 16. Finally, we add all of these numbers together. 16 plus 8 plus 1 gives us an answer of 25. 11001 in binary is equivalent to 25 in the decimal number system. You can also switch from the decimal to binary number system. Let's find the binary equivalent of 19 in decimal by filling out the chart below in the reverse order. This is where it's helpful to know powers of base 2, 2 to the 0, 2 to the first, etc. First, find the largest base 2 power less than or equal to 19 in decimal. In this case, 2 to the fourth power is 16, which is less than 19, so the chart is created up to 2 to the fourth power. 16 goes into 19 one time, leaving a remainder of 3. So we enter a 1,
at the top of the 16 column. Then we ask, how many times does 8 go into 3? So, once again, 16 goes into 19 one time. So 1 times 16 gives us 16 down here. And we have a remainder of 3. So we keep going with this column with this number. How many times does 8 go into 3? 0 times. So we'll end up with a 0 here. All right, so we started out with our remainder of 3. 8 goes into 3 0 times, so we have to keep going. We still have that remainder of 3. How many times does 4 go into 3? Also 0 times. All right, so we end up with a 0 here, and we still have that remainder of 3. How many times does 2 go into 3? 1 time with a remainder of 1. All right, and we had that remainder of 1. And how many times does 1 go into 1? 1. And we're done. So, what we do is we check our work by multiplying out the digits and place values to get the value of each column. Then we add them. So 1 times 16 is 16, 0 times 8 is 0, 0 times 4 is 0, 1 times 2 is 2, 1 times 1 is 1. Then we add these together. 16 plus 0 plus 0 plus 2 plus 1 is 19. We have done it correctly. The binary equivalent to 19 in decimal is 10011. So, how would you read this shirt now? There are only 10 types of people in the world, those who understand binary and those who don't. Well, this is actually in binary, not decimal. What is 10 in binary converted to decimal? Well, in the ones place here, we have 0 times 2 to the 0, and then here we have 1 times 2 to the 1, and then we add those together, right? So 1 times 2 is 2, 0 times 1 is 0. Add them together and you get 2. There are only 2 in decimal types of people in the world, those who understand binary and those who don't. While counting in decimal looks like this, counting in binary looks like this. There are 9 separate digits for counting in decimal, while there are only 2 digits in binary, 0 and 1. When counting in decimal, you roll over back to 0 after you reach 9. However, in binary, you roll over back to 0 when you reach 1. That means that when you're counting in binary, you roll over much more often. Here's how we add 2 numbers in decimal. This might seem simple, but relearning how to add in decimal will help us when we're trying to add in binary. So as you can see, in the rightmost column, when we add 9 and 1, there's no digit after 9. So we carry the 1 over to this column, and we place a 0 at the bottom of the first column. Adding in binary is the same process as adding in decimal. You work from right to left, rolling over when the last digit is reached, in this case, when you reach a 1. Here is how we add 2 numbers in binary. Alright, so in the rightmost column, when we add 1 and 1, there is no digit after 1. So we put a 0 down here and we carry the 1 over to the next column. Then we have to do that again. 1 plus 1 is a digit that's greater than 1, so we put a 0 as a placeholder, and we roll the 1 over to the third column. 1 plus nothing is 1. So 1, 1 plus 1 in binary is 1, 0, 0. Here is another example. In the rightmost column, when we add 1 and 1, there's no digit after 1, so we put a 0 here and carry the 1. We do that again. 1 plus 1, well, we put a 0 and carry the 1. 1 plus 1, we do it again. Place a 0, carry the 1. 1 plus 1, there is no 2 in binary, so we have to roll over. We put the 0, carry the 1. 1 plus nothing is 1. And there we go.